Hello everybody, welcome to another video in which I try to explain physics as simply as possible but not simpler. Today we move to the solving problems regarding uniform motion. So if you haven't watched my introductory videos about this topic, please check them. They are available here and also in the description below. So the problem, which is inspired by the Polish textbook by Mroszczyk and Salach, the name of the book is in the description. So the problem is as follows. The tourist walked 8 kilometers in 2 hours going north. Then he rested for 30 minutes, headed west, and walked another 6 kilometers in 1 hour. Now let's first draw this situation. So the tourist starts somewhere here, then he goes 8 kilometers to the north in 2 hours, then he takes rest. He relaxes for 30 minutes, so it's half an hour, okay, to have the same units, and then he goes 6 kilometers to the west in 1 hour. That's basically what's going on, and our first task is to calculate the average speed of the tourist during the entire described trip. So I recall that average speed is calculated as total distance divided by total time. So total distance is 8 kilometers plus 6 kilometers, and total time is 2 hours plus half an hour of the rest plus 1 hour. So it's like this. So what you get? 8 plus 6, 14 divided by 3.5. So it's exactly 4 kilometers per hour. That's the average speed. Second part. Calculate what average speed an application with an autopause function would show to a tourist. That is an app that doesn't measure time when the tourist is not moving. So such an app, it's a common feature in apps, mobile apps for tracking activities, sports or touristic activities. So it will not take this half an hour of rest into account. So of course the formula is the same, but and the distance is doesn't change, but when calculating time, we will not take this half an hour. So we will have just 2 hours plus 1 hour. So we have 14 divided by 3. So this is 4 and 2/3. So this is approximately 4.67 kilometers per hour. So of course this is greater than this. And the last part of this problem, calculate how far from the starting point the tourist was at the end of the trip, measured along a straight line. So if we connect the starting point and end point by the straight line, we have a triangle with the right angle here. So let's say this distance is length of delta r vector, so change in position or displacement vector. So we can calculate this using geometry by the Pythagorean theorem. So that's square root of 8 squared plus 6 squared. So that's 64 plus 36, so that's square root of 100, so that's exactly 10 kilometers. So of course, in straight line, the starting and end point are closer to each other than if you measure along the tourist's way. Okay, that's all about this problem. I will show you another problems in next videos and another topics. So stay tuned and please ask questions in comments if you have any.